Good morning. Hello. Welcome, everyone. We are going to go ahead and get started. I'm impressed that this many people showed up to an 8:30 session, so good job. I will give you a brief intro. My name is Brendan, and I like C#. It's a pretty good language. So as part of that, I am here to talk to you about two main things. The first one being, what is currently available in C# that you might not know about that you should be using. And then the second thing is what is coming down in C# 8. So I guess my first question here, who here knows what version of C# you're using, for those of you that use it? Reasonable number of people? Okay. That's kind of what I figured. Most people don't know, but some do. Let's go ahead and start talking. The first thing that I want to mention to all of you is, I hope you all got caffeine. We're here for an early session, so let's wake up. And the second important thing, if you watched the movie last night and you spoil it, I can assure you this man right over here will take you out of the event. That's his job. Okay, so I mentioned our agenda already. We're going to talk about what's currently available in C# and what's coming. So some of you know what version of C# you're running, some of you don't. I'm going to tell you all how you can select it right out of the gate, because there's a couple of things I want to point out, because if you do want to try any of these features at home, you might need to change it, and I'll give you a quick explanation of that before we look at the features. So if you go into the Properties menu of your project, you're going to see a Build tab. You're going to want to navigate to that. Once you're in there, there's one important change that everyone forgets about when they explain how to change your language. You see this little configuration option here? On the last slide, you'll notice it always starts at debug as the one that you're on. That's because in Visual Studio, you're running in debug configuration, so it wants to change that. If you don't switch that to all configurations, you're going to build your project, you're going to deploy it, and hey, for some reason, when my build server runs this for the production environment, every new C# feature I use breaks because it's not actually turned on. So flip that and then go down to the Advanced button, which you'll find at the bottom, and you're going to get this nice little window that pops up. You're going to choose the version you want, and you get this giant list that you don't have any idea what to do with. This literally has original versions of C# in it. It's hilarious. I really only want to focus on these ones. So this is the set that we're going to talk about today, essentially 7.x and 8. Most likely, if you're in this room and you're running a relatively modern application, you're probably running on C# version 7. So that's the first one in this list. If you upgraded to VS 2019 earlier this month, you have these set of options that I'm showing you here. The adjustment that they made with that is that you now have as the default to use the latest supported minor version. What that means is you are probably running on 7.3 if you upgraded everything. If you didn't, you are probably running on C# 7. Today, we're going to go ahead and make sure that we turn everything on all the way to C# 8, because you guys want to see that. So let's jump through that. The alternate way that you can change these, other than using the menu, if you are in .NET Core, which if you are, congratulations. I really love being on .NET Core, and I hope you do too. The thing that we get is very nice project files. If you're in Visual Studio, you can just double-click on your project file now. It actually opens up the XML so you can take a look at it. And all you have to do is specify language version. Who here is using .NET Core? Reasonable number of people. You're all on ASP.NET Core 2 of some kind. If you're on 2.0, I have one warning for you. If you haven't gone to 2.1 and 2.2 yet, I highly recommend it because you literally can't upgrade to a newer version of C# because they messed up the C# compiler and it doesn't read that file correctly. So there is a workaround. You implement your own version of the C# compiler class and tell ASP.NET Core to run it. Don't bother like trying to really read what that's doing, but it basically, they didn't parse it correctly. So they were not expecting 7.1. They expected it to always be like 7 or 8. So the fact that Microsoft now does point releases actually broke their own stuff. It was pretty good. Okay, so let's talk about C#. So that first part, that's just so you know how to change it in case you want to do that. Again, all these slides are going to be available after the fact, so if you want to look it up, you can do that, or you can just Google for how to change your C# version, and it will probably explain it. Just remember, if you do that, if they didn't tell you to switch it to all configurations, do so. Okay, so at the beginning of this, I am actually going to mention like 2 or 3 C#6 features, even though I told you it was going to be C# 7, X, and 8. Only because you should absolutely be using these, and even like Microsoft employees who are part of their dev relations team somehow didn't know about some of these C# 6 features. I don't know. So I keep the slides in here. So the first thing I'm going to talk to you about is auto property initializers. And this is literally one of those features that 7.2 was out when Scott Hanselman did a presentation and talked about having just learned about this feature. And I sit there and I go, yeah, okay, I guess we'll make sure that we show that. So essentially, if you have any auto properties in your code, as of C# 6, so everybody in this room should have C# 6, you can just assign it in line. Now, what this actually does is this sets it at the same level as if you'd assigned it from a constructor. So your constructor class assignment is going to be exactly the same. What that means is, if you wanted to use a read-only property, so you just remove the setter entirely, this assignment still works because it's treated as if it were a read-only property, and thus you're allowed to assign it from a constructor. So by that same token, you could have written it like this if you wanted to assign it in the constructor. It just seems weird to people to set a property that doesn't have a setter. Okay, next thing I want to talk about, because this happened in essentially every update of C#, the addition of expression-bodied methods. And I need to make sure that you all see this, because if you don't know these, you're going to run into these everywhere in your code, because someone in your code base is going to use them. Essentially, the idea is this. Instead of having a full declared body of a method, so all the curly braces and everything like that, you can instead assign an expression to it, and it's going to use the same syntax as the lambda expressions do in C#. So essentially, you do this. So this, functionally, is the same thing as the previous code we were just looking at. We have our isSquare method here in this is just assigned to the calculation of whether length equals width. And that will determine, hey, is my rectangle a square? And it works pretty well. One point of note that I do want to make sure I mention here, the parentheses there after the word isSquare. I want you to make a note of that, because this is called an expression-bodied method. If we look at an expression-bodied property, so this is standard property defined with the explanation of what it is. The expression-bodied property does the same thing as the expression-bodied method. Literally, the only difference in this case is whether or not the parentheses exist. Now, obviously, if my expression-bodied method had taken in parameters, it would look different because it would have the parameters, but literally, whether you included them or not is all that differs for them. Okay, so that's essentially what they are. They start to look a little weird because that equals greater than, that makes that little arrow there, just kind of lets you write it a little differently. It's nice for these little helper methods when you need to get to a Boolean value or something. Super common for extracting the contents of an if statement, for example. I'm not going to go into all these ones because they work the same way, but in later versions of C#, we have gotten the addition of both constructors and finalizers can now have expression bodies, as well as the individual getters and setters. So you're going to start seeing that, and I believe even a lot of the refactoring tools, ReSharper and Visual Studio, and a lot of those will end up creating expression-bodied getters and setters now. So just watch out for that. Make sure you see that and understand what it's doing. And then the last thing I want to mention from C#6, because everyone in this room should be using it, string interpolation. If you're not using this, please start. Everyone here use string interpolation, I hope? Yes, good. That is almost everyone in the room. Okay, so quick explanation of string interpolation. Interpolation is a fancy word that just means insert something into something else. So in this case, when we say string interpolation, we just mean, hey, we're going to have a string, and we're going to insert variables directly into it. So unlike string concatenation, this works more like string formats. So you define the template and put in the values, but instead of doing like, the curly braces with 0 and 1, instead we now have the actual named value directly in there. So this makes it easier to read what you're actually creating. Did anyone here ever have arguments with people over whether you should use string format or string concatenation for something? People have had that argument? I know I've had that argument. And you get the one person that says, but string formatting gets it in the right way so you can see what the string is you're creating. And the other person goes, yeah, but I can't see the values, so I want to do string concatenation. And then there's this stupid argument. This solves it, so hooray. Also, look, you can use expression bodies for it too. So we had this, and then we're just like, hey, expression bodies. So it's nice and short. Okay, the next cool thing that I want to make sure that I mention is the name of expression. So especially for like the standard use case of this is an argument exception, where what you need to do is you need to specify the name of some variable. So in this case, let's imagine that we have an argument ID that gets passed into our method, and we need to report that as the argument that had an invalid value in our argument exception, which is what this is. That second parameter there, that nameof ID, will actually put that in here. The nice thing about this is that if you are using any refactoring tools, it will automatically rename that variable if you rename it somewhere else, because you actually get type safety then, whereas if you had just put a string literal, you wouldn't have that anymore. So name of expressions, they're kind of useful. And now to the fun stuff. Again, I've given this talk in different formats with different versions of C# that are out at different times. And this is a feature that I'm betting most of the people in here are using, at least I hope so, and would get cut if not for what's coming in C#8. So I'm going to allude to what we're going to be discussing later. Who here uses null conditionals to do null propagation? Yes, good. As a large group of the people. Okay, so the reason I put both names in here is because I want to explain this to everyone because there's a lot of confusion about this. Null conditionals are what we're going to use. What they do for us is null propagation. So just want to clarify that name so that people get it. So if you've seen code like this, the reason we do it, because I know most of you probably haven't run into this before, is if you don't check for a null, there's this really obscure error. It's called a null reference exception. I'm sure none of you have seen it. And, well, if you run into one of those, your code stops executing, which is not fun. So before you try to access, essentially before you dereference the user object there to access its nickname property that we see there on the last line, we need to make sure that it's not null. So we can do that an easier way than this. This is called a null conditional. So for anyone in the room that hasn't seen or used these, essentially what it does is it says, hey, If the object to my left is null, I want you to propagate that null, really default value, I should say, not null, to the value to the right. It happens that, objects you have, the default value is null, so we are going to propagate a null there. So the return value at this point is going to be null if user is null. Does anybody see a problem with that? Well, the problem is our previous code had us returning an empty string if that value was null. So we're going to add the null coalescing operator on here as well. And then it says, hey, if user is null, then make sure that nickname is null as well, is essentially what it does. And then the 2 question marks there is called null coalescing. And that says, if the left-hand value is null, use the right-hand value instead. So in this case, we said, if user's null, we return null. Otherwise, we return an empty string. Works just fine. The next thing I want to talk about is that you can actually, and most people don't use these, but they're kind of cool. It's not just question mark dot. It's question mark and then whatever operator you're using to get to some value on the object. In this case, we index into it. So you can actually, if you want to safely index something that's potentially null, you can put a question mark before the open square braces. Anybody here know what the bug is in this code? How can this throw a null reference exception right now? Or, well, sorry, how can this throw an exception? It's not a null reference exception. Anybody know? What's that? No, so the property name is going to be there, otherwise it wouldn't compile. And we are empty array, exactly. Yes, we are not protected from an empty array in this case. So if the array has a null value, we're safe. Because we said if the value at point 0 is null, propagate that onto the name. But we can still have an index out of bounds exception on this. So I do want to warn people about this. This isn't total safety, but that is still pretty nice to be able to do. If you get into complicated structures where you're having to do question marks all down a line, it can get really ugly, where you're like going through like 3 or 4 nested properties. That's what they're trying to solve with a change in C#8. So we're hopefully going to get rid of this mess of having, you know, long chains of null propagation going on. Okay, the next thing that I want to mention, because I'm a big fan of this and it comes up frequently enough in our software that we should be using them. Who here is a big fan of output parameters? Anybody? Ah, no, I was just kidding. Almost nobody likes output parameters. And the thing they dislike most about it is that that you have to declare a variable before you even call the method, and then you're expecting the result from this other spot that went in. It's like, wait, what are you doing? Okay, this is really strange. So it's still strange in C#7, but it's less bad. We have now output parameters instead of output variables. Or sorry, we have output variables instead of output parameters. See, I messed up a slide. I told you I would. Okay, so here's the idea. Look at the line on the lower line. All we've done here is we literally put a variable declaration to the right of the out keyword. And what that's actually going to do is it is going to create that variable literally within that if statement there. So right in line, it's going to get created. The scope of that variable is the same scope as the if statement, though. And what that means is you can use that in the main part of the if or in an else, and it works just fine. So if, for example, you wanted to reuse that variable for something, grabbing the default value, you are totally welcome to do that. It still exists. It's not scoped to the inside of the main part of the if statement. It's not within that code block. It functionally works the same way it does in the C# one, where the variable was declared before the if. So you do not mess up scope if you do this, but it lets you inline it so you don't have to have the messy extra variable declared elsewhere. Occasionally, the only way that you have to really validate something is to use an existing method that uses an output parameter of some kind. And there are other instances of what I'm about to show you. But there is a feature in C#7 that now that we're using output parameters more, and especially now that tuples exist, by the way, we're going to talk about tuples in a little bit. Although, if you'd rather say tuples, I can say that as well. Because those are becoming more common in C#, this feature is also more important to know about. This is called a discard. A discard essentially means you put in an underscore as your variable name. And when you do that, C# will essentially ignore it. That variable doesn't exist, it's thrown away, the value you put in there is just kind of lost. It basically just gets rid of it immediately and lets you just move forward. So in this case, I was using a try-parse method just to see whether or not the enum that we received was valid, and I didn't actually need to convert it. I just wanted to check the input. And so I can just throw out the value and just move forward with my Boolean, because I didn't care about that one. So they're super useful. We're going to see them in other stuff later. So the next cool feature that I want to talk about, and this again is a C#7 feature that I really, really like, is called pattern matching. Who here is using pattern matching today? Who here knows what pattern matching is even if you aren't using it? Okay, a few more hands, but not all that many. Okay, so pattern matching, I like to describe with this little kid's toy. And I really should get another picture because my son's got another one of these. Has anyone ever used one of these toys where you put like the shaped blocks through the shaped holes and it's got to be the same one, otherwise it doesn't make it through? Yeah, well, some people admit to having been kids at one point. Excellent. The other people, they were born this age. Okay, so with pattern matching, I like to describe it with this toy because two things happen. So if you use this toy, let's say you take a round block and you put it through a round hole. After it goes through the hole, what is the result afterwards? You have gained two things. The first thing is you have gained the knowledge that that was the correct shape to go through that hole. The next thing that you have is the object on the other side of the hole. So you have the object at the other side. So you have both the information about its shape and you have it. Okay, that's important because that is literally how pattern matching works in C#. And I will show it to you with this basic explanation of how it works in an is expression in the language. If you look at that, let's look at the second line. So if shape is rectangle rec. And I want to talk about that one first because it's the one that lines up with what I was just saying. So essentially we've said if our shape object matches the pattern of the type rectangle, meaning it is a rectangle, then we want that shape to be stored in the REC variable we've created. So if you look on that line, if you look just to the right of the is, that's a variable declaration. Rectangle rec, right? We've specified a type, we specified a variable name. The nice thing is, if you look at the following line, we can immediately use that variable and its properties. So we now have a rectangle variable instead of a shape. So that's essentially how it works. Two other things I want to point out about this. In pattern matching, we have three types of pattern matching we can do. We can match to a constant. That's actually what happens in the first line. Shape is null. Null is a constant in C#. We can, if we were using, say, numbers, for example, as one of the potential types, you could do like, my number is 7, for example. And that would be a valid pattern to match. The third thing that we can match, other than, so we can match against a type, we can match against a constant, and then we can match against anything. So that's the set of things that we can match against in C#7. I need to specify that. 8's coming with more stuff. So what's the value in that? One of the main ones is this. If you've ever, everyone written code like this before? Cast some value safely, check if it is null. At least a good number of people have probably done this before. Obviously, if the value doesn't if it's not the right type, you get a null, or if the value itself was null, you get a null. So check and make sure it's not null and then use it. Obviously, if we use an is expression, because it checks that value and does the assignment into the correct variable, returning back a Boolean, we can just write it like this instead. And it's a little bit nicer than having the multi-line thing. So kind of like how we don't like the multi-line thing in output parameters. Again, just a quality of life improvement that we have here. The more common case that you see pattern matching is the switch expression rather than just the is. Though I am going to mention a case for the is in a little bit that I want everyone here to use. Switch statements in C#7 are not always the same kind of switch statement that you've had in the past. These ones, if you're doing pattern matching, you can pass in an object and you can literally say, hey, if it's this type, do this. If it's that type, do that. If it's this constant value, do this other thing. And this structure looks pretty much the same as our if statement, except, and a lot of people know that switches are fast because they jump to the correct point. You've probably heard that. They do a mathematical calculation, decide where they should go based on that. These don't. So there are actually two types of switch statements in C# now. If you use the pattern matching one, these execute in order. So it is literally going to check if it's a rectangle first, and then check if it's a triangle, and then check if it's null. So this order does matter. Now, the reason why order matters, other than the fact that something both could have been a rectangle shape and be null, is that we can actually use the when keyword now to define additional parameters. So this is an ugly one, don't worry, don't actually read that code, it's really nasty intentionally, because you can actually change whens to have methods or anything else. You can call whatever you want from that point. So we have said here, if you're a rectangle and you happen to, quote, match the square criteria, then we're going to treat you as a square rectangle and treat you differently. If you're a rectangle that has a length greater than 100, you're apparently a big rectangle. And the third one is also a rectangle. So in this case, our switch statement, literally we always treated it as a rectangle and handled it accordingly. Now someone in the room is sitting here saying, but why aren't we just using polymorphism? Why are we using switch statements? And the short answer is, before you use polymorphism, at some point you had to use a switch statement or something like that to create the polymorphic object that you were going to be using in your code to begin with. So there's always one at the entry point that is the one that creates it. Usually goes in the factory or something like that. And I'm going to show you the use case that I always like it in. And that is, if you're doing web development in ASP.NET Core or ASP.NET, you have probably run into action filters before, or some kind of filters, or a middleware layer, or something like that. And there are occasionally values that get passed into you, that get bound to objects, or used in different ways. So the binding, let's say that you're making a controller. And in your controller, say you want to check whether or not a specific user has permission to access a specific account. Let's say there are multiple accounts in your system, sometimes more than one user has them. So I might say, have a method in my controller that takes an account ID, or I might have one that takes a full account object for some reason. Or I could have one that does operations on any number of accounts. Maybe I want to start up a new campaign for all the accounts I have access to. So it takes a list of account IDs, or maybe it takes full list objects. The point is, I don't always know, and when I'm writing my action filter that's going to check that permission, I want to be able to handle them all. So what I can do is I can create an attribute that does this and takes in essentially the name of the parameter that I want to use. So we could also use like a name of here potentially if you wrote it correctly, but that would get complicated. When you do that, your action filter looks roughly like this. You have some kind of entry point. In this case, it's our onAction executing method. It's going to bring in the context, which is going to give us access to all the values. And then we have to determine inside of here whether or not we were given the account ID, or whether we were given a collection of account entities, or whether it was a single account entity. And through that, we can decide whether or not you had permission to do the operation that you were trying to do. So this is a pattern matching approach. And you can tell because we passed in an object to our switch here. We checked to see if it was an int in the first one. We checked to see if it was an enumerable in the next one. And we checked if it was an individual count in the third one. So essentially translating it into whatever type it needed to be at that point. So super, super powerful. I recommend looking into it. And I told you that I was going to tell you one last thing about the is expression before we moved on. I refer to this as a safe null check. So if my variable is null, anybody know why this is safer than saying equals null? Any takers? Guess it's too early in the morning. Who here knows that you can write your own equality for any given object? Yeah? Anybody know what's wrong? No? Okay. Oh, what's that? Correct. This does not run the equals operator at all. It does not depend on iEquality. There is no equality check here. This is not going to check for its own type. So if you've ever implemented iEquality or implemented an equals operator or anything like that, can you confirm for me that you've never made a mistake in that? Anyone? Good, because I can't either. So the idea is, just in case something is wrong, this is just a literal, is that object null? It doesn't run an extra operation, doesn't call out to any extra methods, doesn't do anything else. It just checks, is it null? So if you are doing null checks, do this. It is the safest way to do that. It also prevents like some troll doing something horrible like overloading the equals operator to like mess up on null checks or something, because you technically could write that. I don't know why you would, but hey, I don't judge. Maybe you like doing weird stuff with your operators. Okay, let's talk about tuples. So up until C#7 and the addition of these tuples, I would have told anyone on my team that put a tuple into my code to just leave immediately and never come back. The previous C# implementation of this type was just a type, and literally the values that you got out of it were item 1 and item 2. You had no way to name them. Like it was, and it's like limited sets of like how many values you can have. It was just absurd. A terrible, terrible implementation. Not actually built into the language in any form. No actual construction, deconstruction, or anything. It's just a type. And you're like, well then why don't you create any other type that has something about it? Why would you use item 1, item 2? You could create the same type as the tuple type and just name the properties. It's crazy. But hey, they were in the language. Yay, kind of. Okay, but now we have real ones, and these are actually good. The implementation's very nice now. You like how I said that? Okay, so first off, if you are running an old version of .NET, but you are able to use a newer version of C# with it, so maybe your execution environment or something like that doesn't let you upgrade the environment that you're running in, but you can upgrade your language. If you want to include tuples, I switched names again, in your code, you need to include the system.valueTuple reference. Without it, you don't actually have access to use the tuples, and you'll get compiler errors about it. All right, just a warning for anybody that's on an old version. Okay, so tuples. The way that we create them is by wrapping the objects in parentheses. So essentially what you get in our example method here, our safe parse, is we have a return value of the tuple, bool success, and int number. So it is going to give us those values. And if you look on the first line there, where we call the method and store it in the result variable, you can see that a variable gets created, it's a tuple, and it has two properties on it, number and success, matching the names that we used in our method declaration. So we didn't have to create our own type, we didn't have to go create a struct, we didn't have to create a class, and immediately we can just have an object that is type safe, has the names we want, has the values we want, works great. So essentially, this is, as you probably noticed if you looked at the implementation, a wrapper around try parse. So if you really, really hate output parameters and output variables, you can hide them now, or just when you write new stuff, just use the tuple instead. Okay, so that was storing it in an object. If you look at this code now, the beginning 3 lines are what changed here. We did not change the method at all. This is called deconstruction. So this is where a language improvement has actually given us some value with using these. So on that line, that safe parse line, we declare 2 variables, number and success. And by creating them inside of those parentheses, we have told C# that when safe parse is called, we want you to deconstruct the tuple it returns, store the first value in number, and store the second value in success. Anybody see a problem? Yes. So this is the warning, even with names. And I matched the names. The names didn't really matter, the order matters. So that's the important warning. So if you are going to deconstruct, deconstruction always happens in order. So don't expect the names to line up. In this case, I just used the same names, which makes it even more treacherous. So I'm going to show you something that I consider both to be evil and hilarious at the same time. So this is an example of construction and deconstruction happening on the same line. So let's talk about what construction is. So if you look at the code inside of our 3D coordinate creation constructor there, you'll see that on the left-hand side, we are deconstructing a tuple into the fields x, y, and z. And on the right-hand side of the equals sign, we are constructing a tuple with the values x, y, and z. Now, the cool thing about this is that we were able to assign 3 values on the same line, which is cool. The bad thing about this code is that we assigned 3 values on the same line. So I have, when I first talked about this feature before it was actually in the language, I was like, this is a thing that we hope no one does, but occasionally isn't so bad. It's not so bad in this example. If you do it somewhere else, I'm really questioning your judgment, but like a simple thing like, oh yeah, X, Y, and Z, those are all related. But I've started actually to see these in the wild, so if you run into this, that's all that's happening. Create a tuple on the right-hand side and deconstruct that into the parts on the left-hand side. The only case that I can really see it being not totally crazy to do that is kind of what we were just giving an example of, and that's why I have this slide in here, is if you have highly related data, like, for example, the XY of the XY coordinates, totally unrelated for the name, that's clearly a pair, a point, like whatever you want to consider that, that's almost an object of its own, that would be the case where I think it might not be so crazy to do that deconstruction, construction little trick on the same line to do that assignment. But again, use with caution. Your development team might kill you. And don't kill anyone that does this. Murder is still a crime. Okay. So I mentioned discards to you a long time ago and said we'd be seeing them again. Because tuples. So tuples are great, but occasionally you don't really care about all the values. So let's imagine a scenario like this one, where you both need the position and the value. Well, we only wanted to show the coordinates. So we didn't really care what object it was at those coordinates. So we just kind of threw it away. So if you look at the first line there where we deconstruct the getPosition call into int x, int y, and the discard, we have thrown it away. The cool thing about this that I want to point out, there are two cool things. First off, in our previous examples of the creation of the tuple objects or the deconstruction, we frequently use the word var. We use the var keyword. You do not have to use the var keyword. You can use a type. If you use the type like we did here, if the types are not all the same, you have to declare the type with each one inside of the parentheses like I did here. So if you see in this example, in our previous ones, you could just put var outside the parens and say var one time, and it would create all the objects on the inside of the parentheses, if that makes sense. The second cool thing that I want to point out about this, there's no type defined for the discard. So when I said they're throwing it away, I was not kidding. They are throwing that away when you use a discard. C# not caring about the type of something is absolutely crazy. They really do just toss that thing. Okay. So let's talk about the stuff that you might not be using yet. So these I'm just going to jump through a handful. So Microsoft started shipping point releases of C#. So we got C# 7.1, 7.2, and 7.3. Essentially, these are all of the weird features that maybe you need and most people don't, which is why they ended up in the point releases instead of the main line. Things like if you do a lot of async code, you may have run into the problem that you eventually reach the top of your program and you end up in your program CS and main isn't async. So there were workarounds before to make that possible. Now your main can actually just be async and hooray, but you have to upgrade to C# 7.1 to do it. The next one, remember how I told you that you got names on those tuples? Please make sure you upgrade to C# 7.1 or 8 if you actually want those names to be respected. Otherwise, you end up with item 1, item 2 again if you aren't super, super clear about defining them at all points. So if we create an object, so on the line where I declare the pair there, we're creating an object that is a tuple and has properties count and label. In C# 7 instead of 7.1, those would be pair.item1 and pair.item2 because they did not actually infer those type names. You would have actually had to create something that gave them the names somewhere. The next thing, nice quality of life thing. If C# can figure out what your type is because you're just defining it like this and you're using a default, you don't even have to specify the type in it. So you can do that. Quick, easy one. Oh yeah, for non-trailing named arguments, you can now do this in C# 7.2. I thought I cut this slide. Either way, do you guys know that danger is my middle name? It's actually not my middle name. I was lying. Next cool one. Something cool that we got added in C#, oh, God, it was 6 or 7. So you probably have access to it, is you actually have a whole bunch of new number literals. So if you want to write something in hexadecimal or binary, you can actually do that now. And C# 7.2 adds in a really awesome feature, and that is that underscore. So you see how for the binary you do 0b, and then I did underscore, and then I did ones and zeros? So first off, that it used to be that you'd have to write that as 0b0. So there was no gap. So it made it really hard to read because B kind of looks like a 0 to me. I don't know about the rest of you. It does a little bit, and almost a little bit like a 1. It's really bad. But they fixed that. The next cool thing that you might not know about, and this applies even to your regular numbers, not just the binary and hexadecimal numbers, you can actually just put underscores in all of your number literals now. So they have no meaning. They're ignored, but they help humans read the code, so useful. Also, we have hex literals as well now. You just start with 0x. We're going to skip that one. The next thing, if you upgrade all the way to 7.3, we actually have equality for tuples, so it can actually figure out those values and adjust them accordingly. That one doesn't matter either, really. I want to jump to C#8, so let's hop in. So C#8, who in the audience has installed any of the preview builds that include C#8? Anyone? A couple of people? Nice. All right, so C#8 has a lot of awesome stuff in it, and as you know, we're all excited about new toys. So, spoilers. No, that's not a spoiler for this movie. One of the ones that I like is this one. I don't think they've officially given it a name yet. I call it reverse indexing because that's what I'm used to from other languages, and it uses the hat operator. So let's imagine that we have an array of values. They're letters in alphabetical order. Don't ask me why we're keeping letters in alphabetical order and only part of the alphabet. The indices listed below, the 0, 1, 2, 3, 4, 5, 6, 7, 8, those all make sense to everyone in the room. Who here uses a language that has reverse indexing? A couple of people? So most languages that I've worked with use negative numbers instead of this operator. So they would say that the last item in an array is -1, and the second to last item is -2, and so on. And C# is adding in the same kind of feature. Instead of using negatives, they're using the caret, the hat operator, and it's super useful if you want to get the end handful of values or something like that in your string. Occasionally you're like, I need to get like the last 3, which is surprisingly difficult in C# to actually grab the last 3 because you have to do the calculation of like, oh, I'm going to do the length minus this, and then you end up off by 1 because you didn't calculate it right, and it's like, no, we're done with that. Because in addition to this, they also gave us indexing. So we have ranges in our indexes. So essentially, if you just put a number and 2 dots, you can like do an operation that's kind of like a substring. Obviously, if you're range indexing on a string, then it basically is just a substring. But essentially, you just define the initial point and the end point that you want to stop on. And what's cool about this is, because in this example I wrote right here, because I used the numbers 0 through 9, they match up with what those are for those first ones. So 3 through 7 will get you the values 3 through 7, the indexes and the number. The next one, if you start with those 2 dots, you just start at the beginning of your collection and go until that index. So in this case, that gets us the first few, and then that last one, it goes from index 4 all the way to the end. So super, super nice feature. And it works the other way. So if you want to get the last 3 items, you can do caret 3 ... and that will get you the last 3 items of the collection. Now, someone in this audience is probably wondering, what types does this work on? Because I'm showing this with an array. The short answer is, I didn't talk about spans because they're technically a .NET feature and not a language feature, but that is actually the type they work on in addition to arrays. So I'm not going to go into those in depth right now because we don't really have time for it. But needless to say, it should basically work on your arrays and your lists and other collection objects that you've got. And it does it in a fairly memory-efficient way. Okay, let's talk about the crazy feature, the one that's going to break all of our code, in a good way. So we talked in the beginning of this about an obscure exception that maybe 1 or 2 of you have gotten. It's called a null reference exception. We talked about a feature that we could use to avoid it called null conditionals. And this is another step towards handling nulls better in C#. This is going to be a huge one. This will be an undertaking to implement in your projects if you want to try. Essentially, we now have access in C# to define whether or not we want our objects to be nullable. So C#8 is going to let us say, yes, I want objects to be nullable, or I don't want them to be null. So they will not be allowed to be null. And if you in your project add this row that just says enable the nullable context, this says in my code, if I'm not assigning a value correctly into an object, I want you to yell at me about it. So as soon as you turn this on, you are going to get a mass ton of warnings in your code, because it is going to want you to very, very cautiously assign all values at all points, because it wants to avoid any object being null for any length of time. So you get warnings about it well in advance of anything. In fact, well, let's show you the other way you can turn it on. If you're not brave enough to turn it on for a full project, you can define sections of your code to turn it on. I'd actually recommend going this way, because otherwise you're going to have too many errors to actually deal with, too many errors and warnings. So what you want to do is you put these preprocessor directives in here, and you just say nullable enable and nullable disable at the beginning and the end point. And once all your code is surrounded with these, then you can get rid of all of them. But then that is the slow way of making sure this stuff isn't null. So we talked about a couple of different cases that we'd be in with these. There are nulls are allowed, which means that you can assign null. Your objects can have default values of null, and you can just access variables. That's sort of like the world we're in right now. You can also define that you want to disallow nulls, and that's where you start being essentially required to add these things in, and you start getting warnings all over your code and underlined squigglies all over the place telling you about all the stuff where you didn't assign a value yet and you really need to. You also cannot assign things the null value because it doesn't want them to be null, so it doesn't let you do it. This is actually not the world your code is in right now. Your code is currently in, what do they call it? They have a word that they use for it. Essentially, you're in the unknown right now. And the idea is you haven't really defined, because this option wasn't available to you, whether or not you want to allow nulls. Effectively, it works kind of like you're allowing them, though. Let's look at what actually happens. So this is a constructor for a person class. I have defined it in a strange way that should look weird to everyone. I have used the nullable syntax, so that's adding the question mark after the type to middle name, because some people don't have middle names, so we made that optional. The problem is this. First name and last name are not nullable, because I did not define that. So strings are no longer supposed to be null, unless you've explicitly defined it as a nullable type, as I did here with middle name. So when I compile this, I'm actually going to get a warning over my constructor because I did not initialize those values. And I could initialize them either from constructor parameters or default values defined in the constructor. It doesn't matter. So if we look at this, this would actually get rid of the warning. I would no longer have it as long as I assign those values. There will be some cases where you have defined, so remember, we said that middle name could be null. So if I try to use it somewhere, I am going to get a warning because I have not checked if it's null. So it is now going to give me a warning every single time I use a nullable object, which means any object I use anywhere is considered that I've said was nullable. It will say, wait, that could be null. You can't use that until you've checked it. Because I defined that. So what it is going to do is going to require that I do this. If I, as the developer, am absolutely 100% certain that that object is not null because I know that it got set somewhere that the compiler for some reason isn't detecting, I can override it and tell it, hey, I'm really, really sure that this isn't null. Now, you might notice my comment there that says don't do this, because unless you really are absolutely certain, then you risk getting your null reference exception back, because this tells the compiler, That exclamation point dot just says, nope, nope, this really isn't null. Access that property, dereference the object, do it. So that's essentially the spot that you get in. The way that enforces that is through compilation and warnings, whole way through. Okay. Yeah, we're not bad on time. So let's talk about pattern matching improvements. So I mentioned that C# 8 was going to add some pattern matching improvements. The first one that we're going to talk about is switch expressions. So we mentioned switch before. This is a normal switch statement. Perfectly normal. Nothing weird about it. We have a bunch of cases. We return back values. Very important stuff. If we want to write this in the new way, you'll notice we wrote the word case and return a lot, didn't we? Literally, the new way is basically just remove all the cases and return back the result of the switch expression. So I now have a single return before the word movie and the word switch on that first line of the method there. And essentially what this says is, the switch expression is going to get me back a value that I want you to return. And so what we wrote here, instead of having the case statements, we have an individual expression on each line where the left hand is treated as a pattern match and the right hand is the result that it should have when it matches that. The last thing, instead of having a default case, notice the bottom one is a discard. So just like we've seen everywhere else, you can actually just throw a discard in there and it works just fine. And in the case of the discard, instead of returning a value, we throw an exception and said, hey, we didn't have that. So that's switch expressions. The next cool thing I'm going to show you, and we're going to use this in a switch expression as well, is called property patterns. And this is the really neat one. So we pass in this conference object here to our switch expression. So we're switching on a conference object. And we're doing pattern matching on the properties of the object itself. So essentially, I've created an anonymous variable at each one of those lines. And if the properties of that anonymous variable match the values on our object, so if it has a state of Ohio and a name of Star Trek, we're going to call the BuyNow method and return back the receipt from our purchase, which apparently everyone in this audience did. And then our discard at the end, again, does the receipt.none. Remember, as we mentioned, new switch expressions. If you're using pattern matching, it goes in order, which is why our second one can also be Ohio. So the cool thing here being you can match on multiple properties. It could be any property. One of these other ones could be, say, you're not going to go to the conference if the price is too high or something like that. So still works. And this type of pattern matching works even if you're not doing the expression. So you could be using a regular case statement as well, and it also works. So if you don't like the switch expression syntax. In addition to being able to match against those anonymous objects, you can pass a tuple in. So notice right after the return, we construct a tuple out of the parameters to this method and then compare them on each one of those cases. So we check to see were choice 1 and choice 2 those values and return back the result. And then we constructed a double discord example on the bottom of that. So it has that full structure of the type. But if we really don't care at all, that's what my comment is saying over there, you can actually just put in a single discard and it will treat that as a tuple object instead of constructing 2 discards. So I figured I'd point that out in case you see both, either one, they both work. Everybody here know about the iDisposable objects and how you use a using statement for that? And it defines the scope to whatever your curly braces are. C# 8 is actually giving us a using declaration scope. Essentially, you can just put a using statement on the line, declare the object. If you don't define any scope, you don't put the curly braces, and you just end it there, the method you're, like whatever scope you're in, that's the scope of your using. So no more nesting over just because you wanted something to be disposable. As long as you put the word using before it, hooray, it works. So another nice quality of life improvement. We have local functions in C# now, and they can be static. Do I want to get to that last one? Yeah, I know in my time. I can see it. Yeah, well, so yay, they can be static. The last one that I want to mention, and this is where we're going to end this, is default interface methods. This is going to scare most people. Microsoft is actually going, well, this is still a planned feature. We aren't getting to see much of this, but they have not cut this one yet. Interfaces are going to be able to have a default method defined for a type. So you're going to be able to actually put code in an interface, which is going to seem crazy to some people. And I recommend caution if you're going to do that, because you can literally now just define a method in your interface if you're using the new code. Quite crazy. Any questions from anybody about anything? I will stick around for a couple of minutes if you do. So if you swing up here, if you've got questions, I can show you all demos. I actually have all of this running on my computer, and I can answer any questions anybody has. But either way, I want to thank everybody for coming out this morning and hanging out with me, and enjoy the rest of your day.